Good morning, Year 5-6. Welcome to your maths lesson for Monday, the 8th of February. Arithmetic again to start off with, so pause the video and have a go. Okay, and then your answers. So 100 add 1, 101. 2 quarters add 1/8, so you find the same denominator. Partitioned 777, and you've got 700, you've got 7, so missing the 70. 8 times 2 times 1, so do the brackets first to get 2, and then multiply that by 8. 225 times 6, adding the decimals together. Division, either using a short division method, or you could have used long division, and then balancing this out, so working out this side, and then working out what the missing number will be to get the same as this side. Okay, so today we are doing a bit of a recap of calculating perimeter. So the important thing to remember is that perimeter is the distance around the outside of a joined shape. So the shape would need to be complete, so it all needs to be joined together, and it's finding the distance around the outside, so it's a measurement. So you might be measuring in centimeters, you could be measuring in millimeters, kilometers, but today we're mainly just going to be thinking about it as centimeters. So the distance around the outside of the shape, we can, if we have it on a grid, we can just pretend that each square on the grid is 1 centimeter long. So if it's 6 squares along, it'll be 6 centimeters. So we can count 6 along this side, 6 along the bottom side here, and then we've got 3 and 3. So if you were to start here and walk all the way around the shape, then we would walk each of those squares would be 1 centimeter along. So we'd go 6, 9, then 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're walking 18 centimeters around the outside of the shape. So we can say that the perimeter of the shape is 18 centimeters. So it's the 6 plus the 3 plus another 6 plus another 3. And we've got 18 centimeters. And there's different ways you can try and work it out. So you could do 2 lots of 6, add 2 lots of 3, because all of that added together is the same distance around the outside. This is a rectilinear shape, so it's not a rectangle, but it is rectilinear shape. So again, the perimeter is the distance around the outside of the shape. So you might start up here and then count the distance around the outside. So go 2, 4, and then another 4 is 8, and then 10, and then 16, and then another 4 is 20. So altogether, the distance is 20 centimeters around the outside of the shape. Again, that is assuming that each of these squares is 1 centimeter long, which it tells you that there. Okay, some different shapes to look at this time. So again, what we've got to make sure is that, particularly when we get to around here, we're counting each of these lines around the outside of the shape. Every time you get to a vertex, you then have to you're then turning to keep going on that path around the outside of the shape to measure that perimeter. So this would be 1, 2, 3. All around this square here, but each of these movements is another centimeter along. So if we start up here in this corner, we go, so that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 centimeters around the outside of this shape to find its perimeter. And then with this shape, the difference, you would have to then spot that for this shape, each of these squares is actually worth 2 centimeters, not 1 centimeter. So that's why, although it's 4 squares along, each square is worth 2 centimeters. So it's actually 8 centimeters. So it'll be 8 across here. Then going down there is another 2. But then it's 2, 4 going down there. Another 2 here. And then another 4 there. So we've got 8, 10, then 14, 16, 20, and 24. So the perimeter of this shape is 24. So it's important to check what the scale of the diagram is that you're looking at. So when we're looking at on a grid, we've got to make sure that does each square represent 1 centimeter, and it should tell you whether or not it does. Okay, that's it. So time for you to have a go. So there's 6 shapes here. If you can try and calculate the perimeter of each shape, and what we'll say is that 1 square equals 1 centimeter. So we're saying each one of these squares for all of these shapes, 1 square is 1 centimeter. So pause the video and have a go. Okay, let's look at the answers to these. So A, we've got 16, B 16, C is 12, D should have 20, E should be 16, and F should be 18. Okay, some chance for you to have a little bit of an experiment this time. So with this question, which of these shapes has the longest perimeter? And then explore other letters which could be drawn as rectilinear shapes. So not rectangles, but rectilinear shapes. Have a go at a few of them, put them in order of shortest to longest. Could you make a word with some? You don't need to do every letter of the alphabet, but do a few more. Maybe you could do your name or do another word, and then measure the perimeter. And with this one, you need to draw 2 shapes with a perimeter of 20 centimeters, but they should not be rectangles, i.e. they need to be rectilinear shapes, but not rectangles. So use the squares in your maths book, 1 square being 1 centimeter, and draw 2 shapes that have a perimeter of 20 centimeters, 2 different shapes, but they should not be rectangles. So pause the video and have a go at these questions. Okay, so with these two, E has a greater perimeter, which is 18 compared to the 16 for the T, and then it could have been so many different letters that you might have chosen, and hopefully you're able to calculate the perimeter of those. And then with this one again, it was open-ended, so you could have had lots of different answers, but there's a couple of examples here. So there's a shape here, there's a shape here that you could have created. 2 shapes with a perimeter of 20 centimeters. And then finally, the platinum questions. So you have 10 paving stones to design a patio. The stones are 1 meter square. The stones must be joined to each other, so at least one edge is joined corner to corner. So you can't have just one corner touching the other, the edges need to be touching as well. Use square paper to show which design would give the longest perimeter and which would give the shortest. So arrange these 10 paving stones into 2 shapes, one that will give the longest perimeter you can, and one which will give the shortest. And then with this question here, shape is drawn on a square grid. Part of the shape is hidden. What could the perimeter of the shape be? Again, lots of different options for this one. So pause the video and tackle these questions. Okay, let's have a look. So the shortest perimeter would be 14 meters in a 2x5 arrangement or a 3x3 square with an extra added on. The longest would be 22. I suppose doing kind of a staircase. Might be able to arrange it in a different way, or it might have it going in a different direction. And then for this one, lots of different options. One example would be 25. So you're kind of looking what's here. You've got to imagine, like, does it just go straight across here and straight up, or does it follow the symmetry of the rest of the shape and kind of cut in and go across? What different perimeters did you get for this shape? Okay, and that's the end of the lesson for today.